And we're live. Woohoo! This is Fractions Bite, a little bite of fractions for your day. And the topic for this video is what's so improper about fractions? We're going to be talking about improper fractions and mixed numbers. And of course, pizza, because you really can't talk about fractions without talking about pizza. So let me get the first page here. Woohoo. Remember, don't try this at home, kids. Well, actually, I lied. Do all the math at home. It's totally doable at home. Okay, but make sure you have your support system in place because, you know, fractions can be a little intimidating sometimes. Not really that hard, though, once you get comfortable with them. Totally doable. So, what I'd like you to do is to remember from the very first video, if you saw it, that a fraction can be used to count pieces of something. In this series, I've been using pizza. So the fraction 5/6 represents 5 pieces of a pizza that's been cut into 6 pieces. So let's look at this. So the total number of pieces is 6 pieces. This is the number on the bottom. I'm going to eat, because I'm very hungry, 5 pieces. That's the number that I get or you get on top. So let's look at what this looks like in terms of a pizza. So what I'm going to do is I'm going to cut this pizza in half. Now, full disclosure, even though I'm going to create 1/6 of the pizza, I will not be able to divide the pepperonis or the tomatoes, depending on your perspective, perfectly. We're just going to go with it because this is really just pizza, right? So thirds are really tricksy. So part of me really regrets doing this, but let me see if I can get, if this is the center, I think 1/3 would be about there. No, not at all. And 1/3 about there. Not great, but not terrible either. So let's say we cut the pizza and assume that these are equal or even pieces. So my sketch is not perfect, but you get the idea. So what does it mean to get 5/6 of the pizza? So 5/6 is equal to, and then let's see if I can draw a piece. Draw it correctly. Something like that. I get the first piece, I get the second piece, I get the third piece, I get the fourth piece, and I get the 5th piece. So there are 5/6 that are going to me. Yay, or I'll be Godzilla right now. So 5/6 go over here. Notice, interestingly, that there's one last piece. That's 1/6. That's the last piece, piece number 6, that's going to go over here. So Sharktopus has just eaten a whole yacht full of people. So, is not really hungry. So just nibbles on one piece. Godzilla, it's been a while since Godzilla ate Tokyo. So feeling very, very hungry. So this is 5/6, this is 1/6. Notice that once again, we see that a whole pizza is all 6 out of 6. So the whole pizza so this is 5 out of 6 pieces. This is 1 out of 6 pieces. And so the next question that you can't see, but I can, what in the world would it mean for us to get 7 out of 6 pieces of pizza? Well, let's take a look, because this is kind of a weird idea. So let me see if I can kind of fit everybody into the screen at the same time. More or less. Not terrible, not terrible. 7 out of 6 means 7 pieces out of 6 total, which is more than a whole pizza. Remember, the whole pizza is 6 out of 6. So what we want is we want 6 pieces 1, 2, 3, 4, 5, 6. All 6 pieces. So this is 6/6. Plus, we want one more piece. That's 1/6. Oh, I'm writing all these things and you can't see them. So let me talk it through again. Sorry, you guys are being so polite and quiet. How nice. You guys are listening quietly. Or maybe throwing things at the video because I can't see. I've got 6 pieces. 6. I really should have thought about pieces of pizza. Very hard to say, but 6 pieces. So I've got a whole pizza here. This is the whole pizza. So I get 6 pieces there, and I have to bring in an additional piece to get to 7 pieces, which would be 7 out of 6, which would be the whole thing plus one more. So this is kind of an interesting idea. Rather than looking at 5/6 or 1/6, we're looking at 7/6. So we have to bring in a whole pizza plus one little extra piece. Fractions like this, let me hide that, there we go. Fractions like this where the numerator top is greater than the denominator bottom, so 7 is bigger than 6, are called improper fractions. Improper fractions can be rewritten in a form that includes a whole number and a fraction, and that's called a mixed number. So let's look up here again. I could say this is a whole pizza plus this is one piece. So I could say this is a whole pizza plus 1/6 of a pizza. And so this is the improper fraction. Right here. And this is the mixed number. So far, so good? So the big question is, once you know, okay, this is an improper fraction, this is a mixed number, how do you convert back and forth? Because there are going to be some settings where you want an improper fraction. There are going to be other settings where you want a mixed number. So you got to be able to move back and forth between them. So let's look here. I say, first, you can only convert improper fractions to mixed numbers. The numerator top has to be greater than the denominator bottom. If the numbers are small, you can sometimes work it out in your head, like we did here. Now, I know some people are looking at this going, I have no idea what this means. So let me show you 13/6. So I've got 13 pieces. And instead of drawing them like pieces, let me just, I can draw little triangles. 1, 2, 3, 4, 5, 6. There's 6 pieces. 1, 2, 3, 4, 5, 6. There's another 6. So how many do we have? 13 over 6 means each pizza has 6 pieces, and we have 13 pieces all together. I can't fit that in. So let's pretend that I just said all together, but I'm not going to write it because it won't fit. Okay, so 13. So I've got 6 pieces here, 6 pieces here, and then one more piece. 6 plus 6 plus 1 is 13, right? So let's see. This is one whole pizza. Now, these are not all facing the right way, but I can kind of turn them into, make into a pizza. This is a second complete pizza, and there's one little piece left over. So basically what I've got is I've got And in fact, I don't want to write this down here. I lied. I want to give myself a little bit more room. Up here, I've got that 13 pieces where it goes 6 to a pizza is equal to 1 whole pizza, 2 whole pizza. So in other words, I got 6 pieces, so that's a whole pizza. 6 pieces, that's a whole pizza. That's 12 pieces altogether. And then I need 1 more to make 13, because 13 is the number up on top. So 13 is this number. The number on the bottom, 6, is how many pizzas go into a single pizza. So 13/6 equals 1 pizza, 2 pizza, so it's 2. And then we've got 1 single piece left over. And we keep track of what the pizzas look like in this final answer. So either I have 13 pieces, or if I want 13 pieces, I got 13 friends, they each want 1 piece, then I have to order 2 whole pizzas, plus figure out maybe how to get that 1 last piece, like buy a separate slice, right? So 2 whole pizzas plus a little slice. And that's how I would feed everyone. Okay, so the next question is, what do you do if you can't draw the picture? Well, if you can't draw a picture, then we're going to use long division. And I know everybody says long division and goes, oh, yay. But long division is just a way of being very careful with your division. Now, if I were to work out, if I said 13 divided by 6 on my calculator, it says it's 2.1666666 forever. And that gives me part of the answer, because I know the answer should be 2 whole pizzas and 1 slice, but the decimal is not the way we want to write it. And this is a fair question, because everyone always asks me, well, why not? The calculator's got the answer. And yes, that's true, but the calculator answer, we'd have to write a bunch of 6s. In fact, there are an infinite number of 6s that we'd have to write out. And if anything that we write as a decimal, like 2.167, we would be rounding. It wouldn't be the exact answer. And so if we continue to do work with it, we get some kind of wonky answers. So the goal when we're working with fractions is that we keep everything in fraction form, so we don't have to estimate, so we don't have to round, so things don't get wonky. So this is how we're going to do it. Okay, so let's remember our top number is our yellow number. Numerator is yellow. Denominator is blue. And what we're going to do is we're going to remember that there's another way to think about fractions. And the way to think about fractions is division. Now, think about what a division sign looks like, right? Division, you've got a line and a dot on top and a dot on the bottom. Doesn't that kind of look like a fraction? Huh, line, number up here, number down, something up here, something down there, and a line in the middle? Okay, so the number on top starts first. It's 13 divided by 6. Now, you don't have to write this part out, because this part is only the beginning part. Then we have to write it in long division. So you have to remember that 6 goes outside the box and 13 goes inside the box. And what we're going to say is we're going to say, okay, how many times does 6 go into 13? And I think about it and I say, well, 6 goes into 12 twice. So let me do 12. And remember those 2 pizzas? There we go. How many times can we get a full pizza out of this? Well, every 6 pieces will give us a full pizza. So how many of those? They're going to be 2 of those. Okay, remember that what you do is you write down the 6 and the 13, then you come up with the 2, then you say 2 times 6 is 12, and you subtract that. So again, so that we've got these numbers, the blue number, it's kind of weird, The blue number, the denominator, gets written second in terms of division, but we write it on the left when we do the division. Now, it may be that you learned long division in a different order. Feel free to do the long division that you learned, because there are many ways to do long division. Not everybody learns the same methods, and they all work. They're all great. Okay, so 2 times 6 is 13. 2 times 6 is not 13. Oh my gosh, you guys caught me. 2 times 6 is 12. 13 minus 12 is 1. Does 6 go into 1? No. So we're done. We don't have to keep going. That's the great thing. So then we write up here. I learned little r. Maybe you learned big R. Do you guys know what that stands for? Yeah, it stands for remainder. It's what remains. It's what's left over. And it's remainder 1. Okay, now I'm going to need some more colors. All the colors. So I'm going to box 2 in pink. I'm going to box 1 in green. And let's talk about how to read this answer. So when we took the 13 pieces and we divided by 6, we got 2 whole pizzas. So that's 2 as a whole number. But then there was 1 piece left over that didn't make a full pizza. So that's just the 1 divided by 6. So let me box these in their colors so you can see. So whatever the quotient is, this whole number, that is our whole number. Whatever the remainder is goes up on top of the fraction. It's how many of the pieces are left over. And whatever the number of pieces in a whole one, that denominator stays in the denominator. Notice that when I convert from 13/6 to 2 1/6, I'm still talking about sixths. So that's not going to change. Your denominator should not change unless you're reducing. Okay, shall we give it a try? Let's give it a try. Feel free to pause the video. So I'm going to convert 100 over 7. So pause the video, try it on your own. And then when you think you've got it, go ahead and turn the video back on and I'll show you how to do it. Don't worry, I'll wait. I'm waiting. Go ahead and pause the video. Dun, 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 dun. Okay, so welcome back to the video. So if I want to convert 100/7 to a mixed number, first thing I check, is the top number bigger than the bottom number? Yes, we're good to go. Okay, so now we have to remember, if I've got 100 on top and 7 on the bottom, this represents 100 divided by 7, right? I do top to bottom. But then when I write that division, I reverse the order. It's 7 into 100. Now here, I'm going to have to remember my times tables, or let me show you the secret, sneaky thing. If you're allowed to use your calculator, feel free, let's get it out of the glare, there we go. Feel free to try this division. Now, it won't look like a fraction, although some of you have calculators that will do fractions. But if I take 100 divided by 7, now the decimal is not useful to me because I want to look for a fractional form, but the whole number is, that 14 is correct. So if you're not sure how many times 7 goes into 100, you could just try here. Or if I'm going to be good, let me be good and I'll put my calculator away and let's try. So 7 into 100, I don't know that. So, but 7 into 10, that goes once, right? And then I subtract 7. And then 10 minus 7 is 3. And then remember, you bring the 0 down. You bring each term, each successive digit down. And then 7 into 30, well, 7 times 4 is 28. And then when I run out of numbers to bring down, that's my remainder. Does 7 go into 2? No. So I get 7. Oh, no, I don't. Oh my goodness. Seriously, can you take me anywhere? No, you can't, because this is just a video. I mean, I guess you could take wherever you are is where I am right now. Oh, that's trippy, isn't it? Wow, I'm seeing the world through my video. You should go somewhere really cool to watch the video so I can see those places. Okay, let's try this again. We'll rewind. Okay, so let's try it again. Let's pretend I got it right the first time, okay? So 100 divided by 7 is 14, right? We did the long division here. Remainder 2, here's our remainder right down there. And so that means that 100 over 7, let me write 100 over 7, I'll do this arrow, equals 14 and 2/7. Does that make sense? Kinda, sorta. I want to add one more colored thing up top because I'm not sure if we made that connection. Whatever number is left over becomes the remainder. This is the 2 that was left over. That becomes the remainder, which becomes the numerator. That's how many pieces you have left. Now, in this case, if you've got people who want to eat 100 slices of pizza, each pizza has 7 slices. You're going to need 14 pizzas, and then you're going to have to buy 2 separate slices. Or you could always round up and get 15 pizzas. Or you could tell people not to call you when you're making videos. You know, that's an option too. Okay, let's try another one. Now, this one, I'm being sneaky here. So you may already notice what's going on, but I wanted to try one just in case you get yourself into this situation. You're like, what is going on here? So let's convert 10 over 2 to a mixed number. Remember what I said? I said you can write it as a mixed number as long as the numerator at the top is bigger than the denominator. Okay, so that it is. So if we've got 10 over 2, remember that's 10 divided by 2, at which point you can be like, wait a minute, I know this one. I'm going to say yes, yes, but let me show you. So you're going to do 2 goes into 10 how many times? 5 times. 5 times 2 is 10. Wait a minute, what's our remainder? Well, technically our remainder is 0. Now, a lot of times if the number goes in exactly, we don't even write the remainder part, right? We say, oh, that's silly. But 10 over 2 equals 5 and 0 halves. So in other words, it's just 5. Now, you might have already noticed that this would happen because if you reduce 10 over 2, you get 5 over 1, which equals 5. But if you ever just don't notice that this is going to happen or you're not paying as much attention, this is what happens. If you end up with a 0 remainder, that means there's no fractional part. So then, no, technically, is this a mixed number? No, technically, this is a whole number or a natural number or an integer. But I mean, if you really needed, like if you needed me, I would come to the Supreme Court and I would make a darn good argument that this technically could be considered a mixed number as long as you consider 0 halves a fraction. Okay? Kind of woohoo. So then, and I know this video is getting kind of long, there's one more thing I want to talk about. What if you got yourself into a mixed number situation and you're like, oh my gosh, what I really need is an improper fraction, right? So if we start with, say, 2 1/6, and I want to convert it to an improper fraction. Now you're going to say to me, wait a minute, why would we ever want something called improper? And the answer is, well, because we're all rebels. Everyone who's a mathematician is a total weirdo rebel. Trust me about this. We all run with scissors in this field. I know it's unexpected, but it really is. We're like the coolest people you've ever met. Just take my word for it. We are so cool. The other thing is I don't know. I tried to look up what the history of this word, improper fraction. And the thing is it's a very poorly chosen name because improper fractions, the fractions where the top is so big and the bottom is so small, are exactly what we want to work with in algebra. Mixed numbers like 2 1/6 are actually really hard to use. So most of the time, we're going to be using improper fractions. So let's go ahead and see what we're going to do. Now, if we go back, when we're going from improper fractions to mixed numbers, we divide. If we want to go back the other way, what's the opposite thing or the inverse of division? Multiplication. So this we're going to multiply. So basically, I say to myself, okay, if I have 2, then I have 2 whole pizzas and 1/6. That's 1 piece, right? And then I think to myself, oh, our pizzas come in 6ths. So each of these pizzas has 6 pieces. So that's 6 pieces plus 6 pieces plus 1 piece equals 13 pieces. So the number we're looking for is 13 pieces, and our pizzas each have 6 pieces. Now, this is not always practical. For example, if this number were like 42, I would not want to have to sit here and draw 42 pizzas, right? So what do you do if you don't want to draw the picture? Well, I mean, honestly, if you have enough time, you can always draw the picture. However, let's take a look at what we just did. We took 2 pizzas and each one has 6 pieces. That sounds an awful lot like 2 times 6 to me. And in fact, that's what we do. For 2 and 1/6, and let me make sure that my number, so let's see. I want to make sure 2 was the pink number. I want to be consistent with the other paper so you can compare things. You'll notice I use a lot of the same numbers over and over again so you can compare and contrast the different pages. And the denominator was blue. Okay. So what you're going to want to do is you take the pink number, the whole number, and you multiply it by the denominator, and then you add the numerator. So you take the whole number, multiply it by the denominator. How many pieces are in each pizza? This is how many pizzas there are, and this is how many extra slices you need. So it's 12 slices from the whole pizzas plus 1 slice that was just left over. 12 plus 1 equals 13. So it's 13 over 6. And notice that you always end up with that same denominator. Again, unless you're doing some fancy reducing, the denominator from the mixed number to the improper fraction will be the same. Shall we try one more? Yay, woohoo, yeah, let's try it. Dance party. I know, Sharktopus disappeared because some of this is getting pretty complicated, but we're here. I got my support group. I've got my sea carnivores, and we're going to do this. Although my friends have made the case that Godzilla was technically an omnivore since she was willing to eat Tokyo, and that wasn't entirely just a carnivore. And mostly she stomps. She doesn't eat everything. So it could be that she's actually vegetarian. We don't know. I don't know personally. Maybe you guys know her better than I do. Okay, let's do one more. I've got 10 and 3/5. Now again, if I wanted to, I could draw 10 pizzas and count up each one has 5 slices, and then I've got 3 extra slices. Or I follow the process I set up right here. You start with the whole number. Remember, you multiply going this way. I'm going to do 10 times 5, and then I'm going to add the 3. Now you got to remember order of operations. Order of operations says you need to multiply first. So 10 times 5 is 50. So 50 slices in the 10 pizzas plus 3 extra slices is 53. So the number we've got is 53 is on top. 5 is in the denominator. That denominator will stay the same. So the last thing I want to talk about in the last minute, when should you use each type? Now, this is going to be a little tricksy because depending on what kind of math you're using, you might have a need for an improper fraction. You might have a need for a mixed number. And the trick is just to get practice enough so that you can go from improper fraction to mixed number or mixed number to improper fraction, whatever you need. But here are the general guidelines. The general guidelines are that you're going to do algebra using the improper fraction almost always. You almost never use this. So 10 3/5 is a very pretty way to write the number, but mathematically, we're almost always going to be working with the improper fraction. Now, when would you not use the improper fraction? Well, when answering a word problem, you should usually use a mixed number, and I'm going to fix what I wrote there because I don't quite like it. You're going to use the improper fraction to do the work, but you use a mixed number as the answer. Now, why would you do that? Well, if I said, how many pizzas do you need? And you said, I need 53/5 of a pizza. That's going to sound goofy, and a lot of people are going to look at you funny. If I say, how much pizza do you need? You say, I need 10 pizzas and 3/5. So 3 more slices. 10 whole pizzas and 3/5. A mixed number generally makes more sense as the answer to a word problem. So that's usually when we use it. The rest of the time, improper fractions. Woohoo! You guys are awesome. You made it through a very long video. Woohoo! Go out, find the sun, find some exercise, get some oxygen, pet an animal, smell a flower, pet a flower, all those fun things. Make sure you have time for dance party, make time for art, make time for sleeping and vegetables. And I'll see you guys in the next video. Woohoo! Math on. Oh my God, I'm such